Welcome to the project demonstration of fault detection in transformer using GSM and IoT application. So the main application of this project is we are going to get the faults in transformer. So the faults nothing but generally the transformer is dealing with voltage and current mainly, and whenever the voltage is more than the threshold value or less than the threshold value, then it's abnormal condition in the terms of voltage. And the same towards the current also. If more current was there, means more load was connected to the transformer, then these two cases leads to the fault. So in order to eliminate this fault, we need to check them before transformer getting damaged. So these kind of faults will be identified by our microcontroller. Continuously it will monitor the voltage parameter and current parameters, and whenever the abnormality detected, then the system will provide us the audible alerts through the buzzer. So here using this buzzer, and the next step is it will display the so-called fault status on the 16:2 LCD screen, and the same details will be sent to the mobile phone through IoT application. And the next, this is for IoT monitoring purpose, and also it will send the message alerts to the registered phone number, that is the concerned department person number will get message alerts about these abnormalities. So these are the main features: monitoring of voltage, current, monitoring the same on the LCD screen as well as through IoT application continuously. And if is any abnormality detected, for example if the voltage is about 245 or below 180 volts or above 100 or 150 milliamps of current, then in these three cases the system will provide us the audible alerts to the buzzer, and same message alert in the IoT application, SMS alerts through the GSM. So these are the main features, and to execute these features we are providing 230 volts AC input to the transformer, which will step down the 230 volts AC to of 12 volts of AC, and this 12 volts of AC will be converted into the DC as the system dealing with the DC current source. That's why we need to convert the AC to DC with the help of regulated power supply board, so with the help of full wave rectifier and filtration. So the output of this one is regular power supply board is at 12 volts, that will be regulated to the 5 volts with the help of LM2596 voltage regulator. With the help of this voltage regulator, the voltage will be converted into the 12 volts buck converter, nothing but 12 volts DC to 5 volts of DC. That is operating voltage of our remaining electronic components. So here 230 volts AC, 12 volts of AC and 12 volts of DC with the help of regular power supply board, and with the help of LM2596 voltage regulator, 5 volts DC output, that is input to the motherboard. So from this motherboard the system will provide the power supply throughout the input output modules. So input modules is potentiometers for variable voltage and variable currents, and output module is LCD display, ESP8266 Wi-Fi module, piezo buzzer, GSM along with antenna. So these are the connections. And coming to the circuit connections, so we have interfaced these two at A0, A1, and pin number B2 to B7 for the LCD, B0, B1 for the GSM, C6, C7 for the ESP8266, and C4 for this buzzer. So these are the interfacing connections. Before demonstration, first of all we need to insert a valid SIM card. For that, just insert this in this manner, as I shown in this manner. Okay, the notch should be this side, upside, and insert gently, push to lock and push to unlock. So now it locked, and after that just on the power supply to the kit. Okay, and here one more thing is there, this is a reset switch, so which will play the major role in our project. Okay, so press and hold after inserting the SIM card, press and hold till the GSM modem got the signal. So we can see that, right, the LED blinking very fast, right? Okay, so once the GSM modem got the signal, right, the blinking got slowed down. And before on the power supply also, as we discussed, so before on the power supply insert the SIM card, the step 1. Step 2 is on the hotspot, go to hotspot settings, configure the hotspot name to project 7434 without any space, without any capital letter. Password should be 123456789. AP band should be 2.4 GHz. After enabling these hotspots along with 2.4 GHz, and now we need to install an application, that is network analyzer application. Okay, and the next is Juice SSH. So after installation of these applications, now we can on the power supply to the kit. So then hold the reset switch and till wait the GSM modem LED blinking red got slowed down. So once it slow down, that is indication of it got the signal. That's a very important step. So after this, you can release this. Right, after it got the confirmation from this one. And now in the network analyzer application, we can see one device is connected. So everything successfully done. The buzzer will be on and off 2 times. Wait for around 5 to 6 seconds duration. Then it will get right. And welcome message displayed on the LCD screen. And PT nothing but potential transformer, CT nothing but current transformer, voltage and current. So it will be displaying on the LCD screen. Here we can see that values also. You can see one device is connected. Now go to network analyzer application, do LAN scan. See options, LAN scan, do the scan. There you get the 2 IP address. One is your mobile phone and there is our ESP8266. Copy this. Now go to Juice SSH application. So it will look like this. Manage connections, add. So type is telnet, address, copy and paste, which we got from the network analyzer application. Port number 8080. Telnet, IP address, port number. Click on this. Right. So you can see the data streaming into your mobile phone directly. So just using this volume up button, we can increase, decrease the font size. Okay. Now, if any abnormality detected, see, I am increasing the current. So when it crosses around 150 milliamps of current, then it's sending the message alerts, as well as on the application we can see the notification also, high current alerts. So we got the message alert, high current. After message sent successfully, it will check with the status again. If it is less than that 150 milliamps, then no problem, everything is normal. So when the voltage is above 245, so high voltage message alerts and sending the message, and same on the application part. So through IoT application we are going to get the same alerts, as well as SMS alerts also we have received this. You can check. So there the message alerts we have received while we are testing this. Okay, and low voltage. So whenever the voltage is less than 200 volts, right, we set the limit of 200 volts, right, low voltage alerts, right, we can get to know that same low voltage message alert received. So in this manner, the IoT based along with SMS alerts, the transformer fault identification will be done, and with notification alerts through SMS IoT application locally with buzzer indication. Thank you.